Hey guys, it's Edward. So today I have a three-part system design and coding coaching session with one of my clients. In this session, we actually go over some of his system design and coding work that he did for actual interviews. The first part of this video series will be evaluating his Tesla performance. I critique his approach and his answers and tell him where he might have messed up and what he could improve on. And I think that a lot of the talking points that we go over are very critical for being able to approach the system design in an efficient manner and for improving at it. For information about this client, I had been working with him for 2 months before his first coding interview. We spent 4 weeks coding and 4 weeks on system design prep. Originally, we were going for a mid-level position. However, we were able to secure him not 1, but 2 senior level offers, and I think this speaks volumes to the efficacy of feedback sessions like this. So, if you like videos like this, please give this video a like and subscribe, and watch this until the very end. It lets me know that you like videos like this, and if you follow me on my socials, you can vote for what topic I cover next. And if you also want to get coached for your upcoming interviews, you can book me for interview coaching at echantech.com. So with that, let's begin.
I did get more detailed feedback on Tesla though.
Okay, yeah, let's hear it.
Okay, so the first one, which was the system design, and that was answers. I answered in great detail, estimated on a 5-year basis, built out the API interface, DB tables and whatnot. For the key generator service, point of improvement was I could have, I guess she wanted me to go into the logic of the key generator service a bit more. And that's where it's just like, I guess the more cryptographic side of it is what she was wanting me to go into more. And then my why Tesla seemed to be odd to her. Which is
why Tesla? You mean why SQL?
No. Why Tesla? That's just like a behavioral question. Yeah, that. Well, other than that, it met expectations. And for the other question, which was more of a class design, was like there were a few DB design issues where like duplicate data was being written to, I suppose. And I think it's mainly just the DB design and how data was stored. I don't quite understand that. It's possible, but I thought I coherently and clearly built it out as I was doing it. I felt comfortable doing it. So, but overall DB design was the main thing, but it was still fine.
Wait, when you say class design, which problem was this?
This is a problem where it's you build out when to meet.
Oh yeah, when is good, yeah.
Yeah. And
okay, so, yeah, you didn't address data duplication. Okay.
Yeah. And so that was the feedback for that question. Then there was the first one out of, and this is the final one, which is how do you store like rules, like arithmetic rules, like kind of like the calculator problem. How would you store a set of rules that someone creates in a DB? And that's where she said like great problem solving skills, solid debugging, systems design. She felt that the approach was slower than she wanted. But the approach was also straightforward, which is a plus. The approach was a little bit unconventional, which was something that she really liked. And it was just a different just approach from a unique perspective, I guess. And then good system design of it. So yeah, that was the overall feedback for Tesla.
Okay, that's great. So I don't mind slower than wanted because, you know, as long as you're being methodic about it and you aren't burning time being inefficient, like doing some wasted effort, That's fine because
Well,
every
that
single
was
moment.
designed from the start, right? That's
Mhm,
how we approach it, right? Like, it's fine if you spend time up front. It's your insurance,
mhm.
to not fuck it up later on.
Yeah, I think that's probably something that she was like, oh, you don't need to be overly insured. I think she could. I think her risk reward balance is a little different, but overall,
Yeah.
she had everything. Like the rest of the stuff was like, oh, it's unconventional. But then she might not have seen that it's because we invested so much time thinking about the possibilities that we came up with an unconventional design that was properly reasoned. So
Yeah.
that one, I'm going to say 50-50. Definitely, maybe there's some places where we could be a little bit faster, but I'm not going to sweat that. Now, the
Mhm.
class design went to meet you. There was a few database issues. Can you show me the what you did for the solution?
Yeah. Yeah. Let's get into that. I think
Okay.
I saved it. Let's see.
Because I am starting to
Sometimes.
notice a pattern amongst the feedback, but I'll share with you after.
Yeah. Perfect.
Okay, let's take a
No
look.
problem.
So what's this Moami? This is on site for Tesla?
Yeah. This is on-site Tesla, and this is the say you have these like rules, and how do you store this in a how do you store it in a DB?
Okay, so the rules for the calculator, right?
Yeah.
Okay, cool. Let's take a look. Upon order of a car. Wait, what? Car? Oh,
Tesla.
okay. When you're actually the calculation of a price when you order a car. Got it.
Yeah.
Um, okay, so you have like these rules, if registration, then if da. Got it. Got it. Now I understand what you're doing here. And it's based on input fees and or equal. Okay, so basically this is just one glorified switch statement.
Yeah.
And they said that this was a little problematic.
Now this is just an example of what rules can look like.
Oh, they gave you an example. Okay, got it. All right. So then this key series. Yeah, instead of focusing on all this, let's focus on the problem areas. But okay, scroll down. Tell me when you start writing your own stuff.
Yeah. So, um, yeah, I'm still trying to understand the question here. She's giving more examples,
Sure.
response, and so this is where I started like thinking, okay, this is like the operations. So there's like these like predicates that we have to like resolve and get conclusions from, and then this could be an enumeration,
Sure.
and then there's these rules. This is where I start really.
Mhm. Okay, cool. So you start P1, P2, or P3. These are like priorities of rules, or these are rules themselves?
These are rules, predicates.
Okay, got it. Predicate about operation evaluation. So these predicates are like whether or not they apply, or they're um, like
The actual operations.
oh, these are the actual operations themselves. Got it. Okay. So then the predicate, rule predicate, join, rule ID, and then the predicate ID. Okay. So then it's like if country name equal, and then the ID would be like USA or whatever.
Mm-hmm.
I see. So okay. Um, I can already understand why they have some concerns. So basically, the way you have set this up is essentially saying, hey, we are going to have a predicate, a predicate 1, 2, 3, 4, 5, and that's going to be some kind of statement. If country X, then do Y, right?
Mm-hmm.
Or if maybe, or if region X, then do Y, or if
Oh, there's
some.
no then to it. It's just
Oh,
conditional purely.
okay. So this is just purely conditional. So
Mm-hmm.
if country X, and then what did you do for separating them out into tables?
So basically, since we have these predicates, right, these sub predicates,
Mhm.
you could consider this whole thing um, as a predicate as well.
Okay.
And so this would be one high level predicate. This would be one predicate object, another predicate object, another predicate object.
Okay. I'm starting to get something. And then now what about the rule ID then?
So this is where rule ID, predicate, join.
Yeah. So like, how would you compose, let's say, if country equals United States or a country equals Portugal, then add this tax. I assume that's basically what they asked, right?
Yeah.
Yes. So show me exactly how that would work in your table or your or how you
So
set your tables.
yeah, what did you say again? What the
So
condition
like
was?
if a country is equal to some country, like again, Ireland, Portugal, United States, and then execute some rule. How are you setting up your tables like this?
So this would basically be a predicate, which would be on the left side would be the country variable. On the
Okay.
right side would be this string.
Okay.
And so that's either. So here's where it's like my approach I think could have been unconventional, where it's like, but you could also do a predicate of a predicate. And it turns this whole problem into sort of a tree structure then.
And the issue is in the DB. Now, I'm sorry, I understand the picture now. So here's the issue. So the issue right now is that your predicate, whether it's called predicate 1, 2, 3, 4, 5, and you're storing these predicates as actual functions in a database, correct?
Yeah.
The problem is that this is not any better than just having an if statement or some kind of it's like it's not very illustrious. In
Yeah,
the sense
it
that
definitely isn't.
it's not rich. It's very dumb. And I
Yeah.
think with the elegant solution that they're looking for is something a little bit more elegant. So what do I mean by this? And how could we apply this here? So you're storing the rule essentially like if %1 equals %2, where %1 and 2 equal the arguments that you're plugging in. Essentially that just boils down to an if statement. But I think the way
But how do you structure that in an object to be stored in a DB?
So you could just store it as a string. So like it would just be like if %1 and %2, you know? And then I sent it to you like this. And so the %1 would just be like the first argument. And then the second one would be %2. And then you'll use an abstract syntax tree in order to parse that. So basically what you're doing is boils down to storing a code as string. Does that make sense?
That's clever. I did bring up the fact that we could store the strings themselves. And she didn't want to go there.
Yeah.
But
so then
this
what did
is,
you...
I guess, extension of the string idea, maybe, that would have pushed her into that direction.
Okay, but then the predicate, as I understand it, is a function, but the function lives in a database.
Yeah.
So
yeah, it's referential to sub-functions and whatnot. Very, very convoluted.
Yeah, that is very convoluted, and that could be where the concern is, actually. Let me scroll down and see your class definition, because I'm starting to get the picture here. So scroll down. Okay, so predicate type, foreign key, predicate type, enum string, predicate type. Okay, so when you have a predicate, save, evaluate, so you're passing in the arguments, predicate 1, predicate 2, right? Okay. And operation and or I see. I like the tree. I like your tree idea here. This is fine. But then it's like, again, there needs to be like a better evaluation. This is overly complex. I would have tried tackling the very simple solution first. That is if country equals United States, or if country is da da da.
Yeah. I went for the harder and complex case when I didn't solve the base case.
Yeah, that is probably what the concern was, is like you bit off more than you could chew at the beginning, because then now we have this whole discussion about the predicate, but then once you have the predicate, then you need to execute on some rule. So did they ask the follow-up of like, okay, well, now they have the predicate, how do you store the rule? Did you do that? Or
so it's it's embedded in the rule. So that's where I was building out more of the rule or the details. The rule, you mean the details of the actual like comparison or operation, right?
Right, the thing that comes after is because like if the predicate is if country equals United States, then the rule would be apply 10% tax. So was that part of the problem or not?
Oh no, that wasn't.
Okay, so it's literally just these conditional evaluations.
Yeah.
Okay, so again, I do like the tree. I do think it's appropriate. I don't like that you went for that at the very beginning, and I think that is the issue. I think that I would have tried solving the very simple happy case of like, how do I represent a very simple if statement? And so this is where like, if this is where the structure if %1 and %2 could come in. That's like where I would have started personally. And then said, okay, well, we could then after that have predicates of predicates, because then what would happen is that it would be like a recursive solution. So like if %1 and %2, %2, and then after that you would just have like if this was recursive, if, and then parenthesis if %1 and %2 and %2, you know. So then your statement would eventually look like this. And then that would actually constitute some more that would actually constitute valid code in of itself. And then you could use an abstract syntax tree in order to parse that. And so you could essentially write code within a database in order to do that. And then be able to change it in multiple places. So this is something to probably consider. I wouldn't say, I don't know if it's necessarily the right answer because I'm kind of doing this on the fly. But overall, the approach that you gave isn't necessarily wrong. It's the concern is you went for the more complex solution before you didn't actually consider like the very basic happy cases first.
Yeah,
I think that's
I didn't do a full exploration. That makes sense.
Yes. So I think that's where the concern is. But at least now you know for the future. And I think this also, and now going back to what I was saying before about a pattern emerging, I think that the pattern is that you kind of jump into the problem a little too soon. So what I mean by this, the feedback that you told me is that, oh yeah, a lot of times you didn't actually think about the corner cases. You didn't think about Dijkstra's. You didn't think about this. And so I think you become a little bit over eager. And don't worry, this is a very common problem with people who get like very cocksure of their own problem solving abilities. And you're kind of hitting that right now. You're hitting that wall of like, oh yeah, I know what I'm doing. I'm totally fine with this. I can do whatever the hell I want. That is, again, that comes from now that you have practiced so many times and you're so cocksure of it that you just like start skipping steps. It happens to everybody. I can count, like, I can't count the number of times people have fucked themselves over because of it. So I want you to, when going into like problems like for Facebook or whatever you have left, I want you to slow down and evaluate what the fuck can go wrong. I really want you to keep this question in mind. Because if you do that, then it forces you to slow down a little bit more. And then you'll be able to handle a lot of these feedbacks as well.
Noted.
Yeah, so this is both system design and coding as well. And it's like, what the fuck can go wrong? And are there any other options available to me to prevent this? It's like insurance. Think of it like, yeah, that's a good example. Insurance, like you're hedging your risks. All it takes is just one blow up to blow up your entire account or problem, right?
Yeah.
So like with insurance, all it takes is just like one bad client who files like a multi-billion-dollar claim, and that blows up your entire insurance business.
So. Yeah, exactly.